I hope you you can hear me and we can finally start. I will tell you about, well, добре дошли. We'll start sorry for a little delay. I wanted to warn organizers that there should be like increase the emergency level when I touch anything, but okay, hopefully this will be the last problem. I will tell about basically running Drupal on AWS, literally like this. So some simple architecture which cares for which is intended for people who are Drupal developers and who want to explore like options on AWS. Okay, my name is Vadim Valuev. I'm more than 15 years working with Drupal, but not only with Drupal. I'm based in Prague, and here you can scan the links to my profile on LinkedIn. And this session actually is based, or just vice versa, on the there is a write-up on Medium. So if you miss something here, you can go to Medium article and like recall. So who wanted like scanned, who didn't like, you can catch me later. So what is AWS? This is the, say, there's advertising slogans, like copy as is. So they claim to trade fixed expenses for variable expenses. That means that you don't need to buy it, you don't need, it actually, like, these slogans, they repeat themselves. So you don't need to guess how much you can, how powerful equipment you can buy. You can always start with the least possible, say, amount you can scale. If you need to scale, you don't need to guess about your capacity, and it should be cheaper because they run like a lot of services, and like every unit, like unit of data transfer, computation, or whatever, for this reason will be cheaper. So brief overview of like traditional, or not traditional, but possibilities for hosting, running Drupal sites and applications. So I think most of Drupal solutions run on dedicated Drupal hostings like Acquia or Pantheon, which well, have their advantages, have their disadvantages. For some sites, like it's still shared hosting is an option, and another option is just what I mentioned, cloud. Basically, it's either Amazon Cloud or Google or Azure. Well, DigitalOcean, I think they have like very like small share, but still, this is not like an exhaustive list, but okay, like main options are like this. And if you have just questions or like, please ask during, don't wait for the end of the talk. Raise your hand and try to I'll try to catch it. So about Drupal, which use cases are not suitable for like standard solutions like Drupal or Acquia, Pantheon, or shared hostings? For example, like tiny sites like personal pages, whatever, Pantheon and Acquia, they're expensive. In some cases, shared hosting is okay, but it has very limited, say, provides very limited options like for development. There are always like limitations of software that you basically both shared hosting and Drupal-oriented hosting, they provide like this set of fixed software which is very limited, just to run basic Drupal, and that's it. And you may want, well, you may want to upgrade Solver. You may want to like write some small API in Node and use it, and it's not possible. Just it's not possible. The monitoring is also like very poor, to my opinion. It does not like satisfy requirements for mission-critical applications in Drupal, in Acquia or Pantheon. Again, you should comply to their workflows defined by those providers, which which is okay to a certain point, but after this point you cannot change like anything. Again, there's a case of like heavy content, content heavy, and sites with portals which deal with high load, so they should use some CDNs, which again can be used as external solutions, but they are not come together with, say, Drupal oriented hosting. Basic notions about AWS. So the basic cloud consists of regions. So, and everything is bound to region. So, for example, there are several regions in Europe, there are several regions in North America, several regions in Asia. I think Australia is a separate region. And in each region, there are like availability zones. So these are physically like distinct data centers which provide uninterrupted service. So if something goes wrong in one data center, in one availability zone, like normally there are 3 availability zones in a region, so 2 others like function and provide what they need to provide. There's like on the foundation there's a VPC, virtual private cloud, which actually just you should understand that there is. It's when you like register with Amazon, you get, or start something, you get like a default VPC, and that's it. But just to know this. And Elastic Cloud Compute basically is like the most widely used service. It's a virtual server, nothing else. But other than this, Amazon has like over 200 services. So basically, it covers every need for certain budget. Yes, and to me, like 2 main, say, features is like finally grained management model. That means that you can either like you can care for everything yourself. You can get this virtual EC2 and run it as a virtual server and like run all software, like run everything yourself, or you can opt for totally managed solution. Like for example, you can install Drupal with 1 click and just don't care about database, don't care about server, just don't care about anything. Use it like fill with content. It's called light service. So, and it's not like this extreme and this extreme. Like it's small steps in between for everything. And the same with pricing. So you can choose a pricing model, choose service which fits your, say, budget and which fits your like requirements. And also to notice, if you register first with AWS, they provide so-called free tier, so a limited amount of limited services for a year for free. So it's not suitable for any production, but just to play around, it's fine. If you are just careful enough, they won't charge you. So finally, we get to what we are going to build. This is like a very schematic architecture, and it's a sample case, so it's not a kind of bound to particular use case. Just services which most likely you will need. So at the core, there are like a set of EC2 instances, basically services running servers running Drupal. They sit behind application load balancer, which distributes load. Database, well, there's a database, a cloud-native database, which is called RDS, which can be, everything of this can be scaled independently. Redis, again, cloud-native Redis. On the top of load balancer, we can put CDN. We'll put it, but it's like optional, but there is a possibility to cache, like statically cache pages in CDN, and we'll use S3, simple storage service, for storing shared files and for storing backups, because it's like cheap and big file storage. And on top of this, on top of files, we can also file stored in S3, we can also put a CDN to deliver this like very fast. Any questions so far? Okay. So the steps, well, I will go through steps of, say, building this, installing this. So first step is to basically install, create an EC2 instance and install Drupal there. Like, I don't have a demonstration here, but you can catch me, you can write me, I can show you if anyone like wants. So there is EC2 has a console which is after you get used to it, more or less intuitive. And basically, you create a virtual server through the interface, which like wizard guides you through it, and basically defaults are fine. Two things to notice that some of EC2 instances, again, there's like a huge pool of options there. Like, start with the simplest one. You should attach file system, file storage to it, because many kinds of EC2 come without any like file system. It's called EBS. And you should start with a certain image. Again, there is a default image which I consider default, Amazon Linux, which is like absolutely standard Linux, but tuned to running in Amazon Cloud. Personally, myself, I installed Drupal like through Docker Docker setup, Docker for Drupal, but it's totally like optional. The idea is you go there and install a web server and PHP. And so the next step, but the idea is that we cannot install anything that should be shared, like database or files within this server. So we should go for cloud-native database. There are options. Again, according to this finely grained model, the basic Amazon MySQL service is called Amazon RDS, and it provides basically it's a wrapper around different kinds of SQL. MySQL, you can select MySQL or MariaDB. There's Aurora, which is kind of more like more powerful and more expensive, but the same idea. It's like a SQL database. And Redshift, it's a Amazon kind of Postgres. I didn't touch it. So in the simplest case, we create again through the console MariaDB instance of RDS. I don't remember if I mentioned the security groups. Security group is a kind of Amazon firewall. So basically everything has a security group attached, and like don't forget to open necessary ports. That's it. And then there's no difference to installing like Drupal anywhere else. So you have from the console the endpoint of the database. You put it in the settings, and basically you can install Drupal totally like standard way. Okay, but what about shared files, like images or whatever, downloads? Again, AWS has three major storage services, which is EBS, which I mentioned before. It's just storage attached to EC2 instances. It's like this is its purpose. EFS, it's elastic file system. It's just a file system which can be shared, but it's just a file system. And there is like a thing which probably many of you know, S3, Simple Storage Service, which is like definitely it's storage. It's arguable if it's service, and it's definitely not simple. So documentation says it's not a file system, but it is used as file system in many cases. And it has certain features. First, it has a permission model, so you can set up as complicated as you like permissions for any bucket of S3. Second, well, you can use it outside of cloud, so you can run wherever you want your Drupal and use S3 storage. And it can have actions, so it is a service. It's a programmable service. You can do what you want with the files that appear there. That's it. And it also can serve as an origin, so it can be pushed to CDN. And this is the reasons to use it as a storage for downloads. And then again, it boils down to installing a module on the Drupal side and configuring a respective bucket in S3. There are options to how to treat this at Drupal side. I probably will skip complications because something has changed since Drupal 10.1. But essentially, there is a module plug-and-play solution, S3 file system. You install it, you configure it. There is a trick that settings are not just in the file system settings, but every file field has its own settings. So check this also. And if you check store all this in S3, basically it will they will be stored in the S3 bucket. This doesn't work for assets like CSS and JS since Drupal 10.1. Just doesn't. Yeah, this is how we should. It's a bit tricky, but again, refer to this Medium article. I have it there. It's a sample and working permission policy on the bucket to make it public and to make it writable by Drupal. So once we set up this policy at AWS side, everything should work. And also, we need to backup the database. And since S3 is huge and cheap storage, why not? There is again a plug-and-play solution, which I don't like because we have S3 here, S3 there, and we have two totally different code bases handling S3, which is not the only option, but others didn't work smooth. So it is as it is. Again, extension to backup and migrate, which rather straightforwardly set up at the backend. Only thing is that there are keys to communicate because this bucket is private. You don't want to show your backups to anyone on the internet. So this bucket is private. There's not so much complications on Amazon side. There are just keys attached to the user, which you want to use for connecting. They can be stored and used in the setting in Drupal settings to talk to this bucket. Okay, there also to notice that RDS can be database can be backed up on the Amazon side, but that's not MySQL dump. That's just the whole say snapshot, which can be restored on its own way.
Before you move on from S3, can I just point out there's another module instead of S3FS that you can use called File System S3?
File System. I like File System, but because it's an abstraction. It's an abstraction which, on top of which you can put this backup and the other thing. But I think since there are problems since Drupal 10.1. At least I didn't manage to I dig into it rather dug into it to a certain point, so that it doesn't work at the moment.
We use it on 10.2 in production. And I'm the maintainer, so if you want to tell me what doesn't work for you, we should definitely talk about it.
Okay, let's check it.
For the record, repeat question.
Sorry. Yeah, the question was like that there is a fly system, well, basically a fly system driver which has a module in Drupal, and yeah, I didn't make it work personally, but I like it, like the idea of this abstraction. Yeah, so Redis. Again, there is a cloud-native Redis which can be like set up in a rather straightforward way on Amazon. Again, there are options again for key value storage on Amazon side. There's a database called MemoryDB, which again like totally contradicts its name because it's not memory. It is not stored in memory. It is stored on disk. The data, and that's the only difference. But basically, it's Redis, but stored on the disk. Like another option is Elastic Cache, which is roughly the same but stored in memory. So it's kind of cheaper, faster, but does not guarantee data persistence. But we don't need data persistence with the cache. There's also the DynamoDB, which is more complicated. Again, key value storage, but just for general knowledge. So we create on Amazon side this through the console, the instance of Elastic Cache with Redis engine, and don't forget about security group and opening corresponding ports, and that's it. Like install module, like standard again Redis module on Drupal side, and it works. And again, like everything is scaled separately. Like Redis scales on its own. Can be scaled on its own, database on its own, and EC2 instances, respectively the Drupal, on its own. So a bit about how to scale. There are like more industrial solutions like Kubernetes or analogous to Kubernetes, but for Docker containers, Elastic Container Service, and something like I think it's like simpler auto-scaling groups. Which basically have the same idea as Kubernetes, describing the services and limits of running containers. But okay, just a brief overview that there is a load balancer sitting on top of the instances. Instances are grouped into target group. We should set up listeners, basically ports to which load balancer listens, and well, it redirects rules to redirect to the target group. Again, don't forget about security group and opening and closing ports, and that's basically it. On this level, we can, for example, set up the redirection from HTTP to HTTPS. Or we can do it on different levels. Again, there are like cloud-native services for everything, of course, like a certificate provider and a certificate provider and domain name service, and you can like buy your domain and bind it to the load balancer. Again, like manual scaling. It's not like a recipe for like life, but you can create a snapshot of the EC2 instance with Drupal and replicate it. It breaks like all manual like deployment and everything. It's not like the solution, but this is the simplest way to replicate something. Okay, let's now have a look at static caching. Sorry. Oops. Okay. Yeah. Again, like for shared files, there are not so it's not complicated creating a CDN CloudFront distribution on the backend. CloudFront requires an origin. Origin is the S3 bucket, so that's it. And S3 file system model, which we use, has just an option for using CDN. That's it. Well, for content, it's like a bit more complicated, and I'll just jump a bit like forward because two main problems are naming things and invalidation of cache. Yes, in development. Naming things we touched a little bit, that memory is not memory, and simple service is not simple service. And invalidation of cache, basically Drupal has its sophisticated system of cache tags and whatever, but CloudFront doesn't know about this. So it understands only time-based invalidation, which is, again, in most cases not a problem. Like, you don't need your, like, if you have, like, whatever, like, portal, if it's not, like, hot news, whatever, like, you don't need changes to your content appear immediately in the whole world. Like, set 15 minutes as a time limit. This CloudFront respects, like, Drupal settings. So if you set on Drupal backend like 15 minutes cache lifetime, you're fine, and that's very simple. If you want, like, problems or, like, go deeper, there is a purger model which solves this problem, or which can solve this problem. But okay, like a little bit still about setting up things on CloudFront. So we can, and if we set it up, we should make a redirection from HTTP to HTTPS on this level. Again, default, it has a default like redirect, cookies, course policies, like defaults are fine. There is a Xcache header which helps in debugging, so it tells like if it's a cache hit or miss. Technically, again, it respects like Drupal static cache settings, so the page for logged in users are not cached. They are served like bypassed. But I ran into stupid thing that there was like an error, page generated an error like unhandled, and it got cached in the CloudFront. So just to avoid such things, you may set, for example, /admin root as like ignored by this cache. Okay. That's it. And one thing, okay, yeah. One thing that we, again, may and could and should, then if we set up this cache, this CDN, to restrict, to forbid direct calling Elastic Load Balancer. So every request should go through the cache. For this, we can set up like a custom header, attach to every request going through CDN a custom header, and set up a rule at the load balancer that if this header is not present, then deny access. So it is simple. Implementation is also like not so hard. The trickiest and I think the least required part is invalidation of cache. Again, there is a purger model which is complicated, which is an abstraction which provides like purgers, queues, and like three like kind of entities. But the idea is that if you set up this correctly and if you crawl the site and everything, it will collect the URLs which needs to be invalidated. And at some points, it will send the packs of these URLs to the CDN, and it will invalidate these URLs. But again, everything comes at a price. So every invalidation of CloudFront costs something. So consider if it's worth doing. And again, like all this, building all these collections of URLs and sending them, and it's like, is it worth it? Is it worth it? Yeah, this I already mentioned, that we should protect load balancer from direct request if we set up CloudFront. Okay, and yeah, last thing is there's also a cloud native solution for implementing search, and it's not Solr, it's Elasticsearch, which it is a fork of Elasticsearch called OpenSearch. Again, you set it up through the console, the Amazon side, and there's a model for this Drupal Search API extension on Drupal side. That's it. Okay, yeah, and just to give an overview, so it's very like there are many questions how when I talked about this, it's just how to run a Drupal site, but there are many things beside this. There are like CI/CD pipeline, deployment pipeline, many options, automation, or depending on your use case, it provides like there's a lot of options. And I gave some examples that like a totally managed solution is a light sail, but you can just install this, install Drupal, fill it with content, enjoy. But you cannot do basically, well, you can SSH there, but no more than that. You don't know about database, you don't know about servers, you don't know about anything. Like there are so-called serverless solutions. Well, like nothing runs in vacuum. Like there are servers, but you don't know about them. They're hidden from you. So it's called like Beanstalk for deploying serverless Docker, like running serverless Docker containers, and Fargate. And I don't really, well, there are like slight differences between them. To scale, again, I mentioned the ECS, Elastic Container Service, Elastic Kubernetes Service, or auto-scaling groups to manage scaling depending on the load. To automate, not to do like manual clicking, to automate deployments, to automate like to handle infrastructure as code. Well, there is Terraform, which is like I think preferred solution, but Amazon has its own syntax, which is called CloudFormation. And I think it's not the only options, it's just what I know. Well, you can always buy bigger EC2 instances if you want. Okay, so to conclude, there are as always advantages and disadvantages, and it's like personal, no, or depending on what your situation, because really you can build what you want. About pricing, like the general opinion is that it is not cheap. So the only case, well, again, in my opinion, when it pays out, if you have like peaks, unpredictable peaks in the load. So you won't buying your dedicated infrastructure for serving like 10 minutes in month, 10 times peak load. That's definitely will pay off. Other situations are arguable. But again, you can set up any software configuration which you like. You can scale, extend. Everything is swappable, so you can pull out using CloudFront. CloudFront and S3 in this architecture are not bound to running everything else in the cloud. So you can use it with sites running elsewhere. you can always swap one service for another, run this Fargate Docker image with the same database or OpenSearch or whatever. So costs are also controllable. There are tools to monitor, to predict, but you should use them. Okay, and disadvantages is that well, it's not Acquia when you just clicked and deployed, and still there's a lot of monitoring windows, a lot of information on the screen, but in fact to make proper monitoring, you need to install monitoring tools like Kibana, Grafana, whatever. It's not enough what goes as default tools in AWS. So it requires certain investment of time and effort. So, questions?